Question 3 is all to do with the iodine. The iodine is the thing here that's the most important that you need to think about. So in the first part of the question, explain why absorbance decreases during the experiment. A lot of students have the right idea for this but don't actually get the mark because there isn't enough information in the answer. So the thought process in my head is, if I've got less absorbance, it means that I have less colour. I have less colour because iodine is yellowy brown, and that's the thing you have to say. You have to say that iodine is coloured. If I've got less colour, it means that I've got less iodine, and there is less iodine as it's being used up. So the iodine that I've got here that gives me the colour is actually being used up in the equation as we go on to form our products, and all of that is needed for that simple 1-mark question. The next question, lots of students got almost the right answers but were out by a factor of 10 or 100. So calculate the concentration of iodine at the start of the experiment and then after 500. If you can't do the first part, it's not actually possible for you to do the second part. So if we have a look here at the absorbance at T equals 0, the concentration of the iodine, we've said, is proportional to the absorbance, and at T equals 0, the concentration of iodine is linked to what's actually being added directly. Now the question tells us that we've added 1 centimetre cubed of 1 mole per decimetre cubed iodine. So here we've got the concentration, and we've got a volume, but because we're putting it into a larger solution, the concentration is actually going to change. So what we need to look at here is that the number of moles of iodine is equal to concentration times volume. I've got a 1 mole per decimetre cubed solution, and I've got 1 centimetre cubed of that. So the number of moles that I've added is actually 0.001. We're not interested in just the number of moles, we're actually still interested in the concentration of iodine. So the new concentration of iodine is looking at how many moles we've got in our new volume. Our number of moles, 0.001, is now in a new volume, and that new volume is 1 for the iodine, 49.5 for our other reactant, and 49.5 for the HCl that we added. And all of that information I've taken from here. So we've got our number of moles divided through by our new volume, which is 100, and that gives me a concentration of 0.01. So my concentration of iodine in the first part of the question is 0.01. The amount of iodine that I added divided by the new volume that I've got for the solution. Working through to the second part, if we know that we have got a 0.8 absorbance representing a 0.01 concentration, this establishes a ratio for us. If we then look at what a 1 unit, effectively a 1 unit of absorbance would be, so divide 0.83 by 0.8 to give us a 1, and do the same on the other side, we know that an absorbance of 1 will equal to a concentration of 0.0125. Now the question's asking me actually, at time 500 my absorbance is 0.18. So if my absorbance is 0.18, I take my 1, I'm multiplying through by 0.18, so I've got my 0.18 absorbance, and I do the same to the other side to give me a 0.00225 concentration. So those are the values that I would expect to have down here for B. Might as well do C while we're here. So for this graph, this was never in the old OCR expected of you in an exam. It was always expected in coursework, and this has come up several times in coursework, this exact piece of graph paper and question. The marks for this are worth 3. 1 for the points, 1 for the line of best fit, and then 1 for the axes labelled with units, and the scale using at least half of the paper. Line of best fit, remember you're looking for roughly the same number of points on either side of the line of best fit with the exclusion of anomalies. I've got my values going up on the side here and my values going across on the bottom here, and terribly you can see that I haven't actually included my axes labelled, so I wouldn't be getting 3 marks for this. So along the bottom here we're going to need to have time in seconds, and on the other axis here we're going to need to have absorbance, and we're saying that doesn't have a unit, so we're going to have absorbance on this side here. Okay, so absorbance here, time in seconds on the bottom, and that's what you need to get yourself all 3 marks for that question.